All right.
Got it going here. Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the DB2 Night Show, and we are up to show number Z137 for the DB2 on ZOS. And once again, we're pleased to have as our special guest Dave Beulke, IBM Gold Consultant, Lifetime Champion. I know people like that, and it's great to have you here, Dave. How are you doing today?
I'm doing great. Thanks, Martin. It's great to be here.
It's great to have you. And any dog noises in the background is courtesy of Lacey, who is as she develops her role as the co-host of the DB2 Night Show. She's decided she needs to say a little more. She's easily placated by giving her liver treats, but she's part of the Chihuahua cartel around here these days. All right, let's move along and get me out of the way so we can get to you. As always, here's our social media, Twitter, hashtag DB2Night. Please follow that. I post information on upcoming shows as reminders, and I also post when the replays are available on YouTube. There's our disclaimer written by some lawyer that the founder of the show, Scott Hayes, had. It says everything you kind of need to hear about. You can read that at your leisure. Again, I know you want to do that every single time we have the show. That's why I'm not giving you enough time to do so. But you can pause it on replay if you need to. Other quick announcements, polls, and then we'll get on with things. Last two shows. The next one will be the Z show. And that will be by Soumya Kamaswaran of the IBM Silicon Valley, talking about the user experience transformation strategy. Another way of saying that is it's an app dev update. And following that is Callisto Zuzart of the IBM Toronto Lab on our last LUW show, which will be on the machine learning optimizer, getting an update there. We had John Hornibrook on earlier, and it didn't seem that people were getting the full understanding of the ML optimizer, so we decided to have Callisto on to explain it to everyone. But normally we have the LUW shows first, but this time around I had to change the date from the 2nd because I'm going to go see a mountain with my daughter and granddaughter, so we're going to have it on the 23rd. As always, DBI is the founding sponsor of the DB2 Night Show, and we like to promote or make you aware of the tools that DBI supplies for both DB2 LUW as well as now with SQL Server. So you can go out to their website and see that information. We encourage you to do so. Our winner from last week is Robert Leadham of FedEx. Congratulations, Robert. There's a gift certificate coming your way. And there's our sponsors, and I should have a funny joke or something, but I really didn't get around to putting anything in today. I will just mention that I did actually play a concert on the weekend. I played some Mozart's Requiem. I was honored to have that opportunity. I never thought I'd get a chance to play it. It's a pretty hard piece of music. And for a guy like me who does other things besides play trombone, it was a real opportunity. I got to bring out my little trombone. I have an alto trombone, and I got to play that for the first time in public, and that was also a treat to do that. So that was my last weekend. I have a picture, but I didn't get around to putting it up. So let's get on and do the polling questions. What'd you do up there? What you doing? The standard question here. What's the highest version of DB2 you have in production? And not seeing any V13 just yet, but our audience right now is all V12. That's wonderful. That's a good thing to see. We've got everybody voted, so we'll share the result and show that everybody's on V12. little more on the lower function levels, and then we have people on the higher function levels as well. We'll hide that. Oh. And next is what you're doing with DB2 LUW. Guess if you don't have it, I didn't give you a chance to not vote for it, but that's okay. And again, we're seeing people on newer stuff. That's also a good thing to see. And we'll close that off. Just keep things moving here. And we're seeing most people are on 11.5 and on the newer releases. V12 looks like it'll be, I'm understanding it will be next year now. So there are various modification levels on that as well. The last thing we have is when do you plan to move, or the next thing rather, when do you plan to move to DB213 on System Z? And we're getting people voting on that quickly. Thanks for that. And what we're seeing so far is 45%, nearly half the audience will be doing it soon, and the other half will be doing it later, likely in 2024, which is kind of makes sense because the next 6 months is kind of like the rest of this year anyway. They're kind of a redundant question. It's interesting how it's important to make up meaningful questions. And the last thing, last question before the Dave. When did you last do a performance audit? And, this is getting quite a wide range of results.
Yeah, I was talking to one of my clients, and they said every day is a performance audit. We don't have to do it.
Well, I don't know if I'd call that an audit. I'd call that getting out the fire hose.
Yeah, exactly.
But everybody has it, as the old saying goes, what have you done for me lately, right?
Exactly. Yeah.
It reminds me of an off-color joke, but seeing as we're recording this, I'll have to remember to tell people later and offline.
Yeah, tell me in Philly.
I'm not going to Philly. I'm just cutting back on. I cut back on some of my travel.
I'm sorry to hear that.
Yeah.
We'll miss you.
Yeah, I would have loved to have done it in a way, but it's always the decisions that we have to make these days, and getting to a point where some of these things I might I'm doing later, or a lot less than I used to. Okay, Dave, I'm going to pass control over to you.
Okay.
And you should have that little clicky box there.
Yeah.
And there you go. We're seeing your screen and you're in presentation mode. As always, I will follow the question and answer.
Okay. If there's any questions during the presentation, just put them in the chat and I'll be happy to address them.
Yeah.
I'm Dave Beulke.
Yeah.
And we're going to talk about DB2 and Java performance best practices. I've been doing Java for a long, long time. And this is some of the presentations I've done over the last 39 years of iDoug. And this is my current table of contents for my DB2 Java performance class. Starting to get into the cloud, but what we're going to talk about is billions of SQL statements a day and tuning that stuff up so that it works and it works consistently and it gives you no problems. But to boil it down, everything that you're going to hear about, there's 4 overwhelming, most important factors that you're going to get into. Java connections are usually managed poorly, if anything. And this goes and affects commit scopes. It affects iteration patterns. It affects JVM, affects garbage collection. It affects everything. So managing the connections is very, very important. Always, the Java application programmer thinks that they can code something better than using the standard routines. They think that they can do it better than the database. They think they can do it better than a framework. They think they can do it better. This is usually not the case, and the reason somebody came up with that routine or came up with that procedure is because it was optimized for performance and optimized for memory, CPU, I/O, etc. The other aspect is unit of work processing, and this is where you get into, all my Java processes that come into the environment have to be consistent, commit their work frequently, and be able to roll back and recover and restart. So processing a unit of work is very important, and often that gets lost in the design and is often confused. And of course, the database is paramount in performance because it can put things into cache, into memory. The SQL can be optimized. When I talk about optimizing SQL, I'm talking about optimizing SQL to the 4th decimal digit. Even 1/10 or 1/100th or 1/1000th of an improvement in an SQL statement can make a huge difference when that SQL statement is referenced billions of times in a particular day. So these are the 4 overriding factors that we're going to also talk about, but these things are the really core of the issue for performance problems. I've been doing performance analysis and data engineering, or whatever you want to call it these days, for a long, long time. I started programming Java in the 90s and working with the client-server people way back when. Java has progressed from the other systems to be as old and stodgy as COBOL is these days. COBOL and Java have a lot in common. Java is just a little more temperamental. So you can do these things after hearing what I'm going to talk about. But this presentation is the 10th version of this presentation, and it's been modified over the last 4 years, the 10 different versions. And it talks about all the consulting clients that I've done with performance reviews and the different things. The names will be changed to protect the innocent or withheld, but all these things are true. And this performance problem that I'm going to talk about is basically an amalgamation of many performance problems that have occurred at different clients. So performance problems are never convenient. They always start first thing on Monday morning. I was at a client for an extended period of time, and of course, Monday morning, all the vice presidents come in asking about the developer testing that was done late Friday and over the weekend. And there's always performance problems. Misery loves company. So you always ask the who, what, when, where, and why. One of the things that I really, really hate is trying to debug a new Java performance problem from a very new developer. If you've got established developers, you usually know what to expect. They're following the standards, they're following the development, the QA. But if you got somebody new, it could be the wild, wild west. So I really try to work with the management to make sure that the new people get the training in the standards and in the development QA processes that we've got. Other things is some of the new vice presidents and some of the new developer team managers don't understand what the expectations should be for processing a billion rows of data or executing a billion rows or executing a billion SQL statements. So the iteration process really needs to understand, so you really need to set expectations properly, and we'll talk about that more. One of the things that has really helped me be successful is set up the right infrastructure for testing so that you can have a realistic understanding of what the testing procedures are and scale up your testing within your environment. We have a 1/1000th set of data. We have a 1/100th set of data. We have a 10%, and then we have a single partition type of scenario in our testing environment where we have actual billions of rows in our test development environment. It's still just a fragment of what the scale up for production is, but it gives us a good sense of what type of performance we're going to have. And this is where you get into, is it a snafu, is it really a performance issue or not? And that's the things you need to do. When you get into a performance problem, the first thing that you really need to do is have the infrastructure set up so that you can gather all the statistics about the performance problems. And this is becoming increasingly difficult as the production access to all the different environments, all the different settings, and all the different things that you need to grab are secured away within the environment. Securing the cloud, the pods, the Kubernetes settings, all the different things that are happening in the various, ZOS, the pod, the Kubernetes settings, the Spring Batch settings, the Hibernate settings, all that stuff needs to be gathered when you're gathering up all the information for the performance problem. Rarely does a DBA or a performance engineer or a manager, a single manager, have access to all those different environments and all those different settings. So you have to partner up with your other people that are monitoring these environments and have them ready so that if a performance problem happens, you can gather all that Sysplex information, that pod information, that cloud information, and gather the statistics on CPU utilization, zip exploitation, availability, Db2 parallelism, all that stuff. One that has gotten us recently is different WLM priorities within the different environments, and also within the priorities and the WLM type settings within the cloud. So you really want to partner up so you can grab all the statistics as quickly as you can. The other thing is, when you get into some of the new Java techniques and processes that are happening, there's a lot of frameworks that are available. One of the ones that I've been dealing with lately is Spring Batch. And it framework where it partitions out the work into chunks. And in this performance example that I'm giving, we have the one Spring Batch chunk that is doing all the work, and it's locking up all the subtasks within the partitions and within the boundaries. So you can see very quickly that we have a major issue. Also, looking around in the environment, we saw that another process was dunking the systems and soaking up huge amounts of CPU. And it had been started the previous weekend, and it had been running for 7 days, and nobody in that development group even noticed. It had done 64 billion get pages. Luckily, it had been managed by a workload manager to barely soak up processing after the first 8 hours. So this was a complete mess. Within this 167 hours worth of processing, it was trying to reference our 330 million customers, our 18 billion rows of data for those customers, and it had done 64 billion get pages. So how many times did it get the same page is an interesting question to ask the developer who came up with this logic. And this was a complete mess also. That's probably going to be my version 11 speech. So when you start to look at the frameworks, one of the frameworks that I've been dealing with lately is Spring Batch. It's a read, process, and write concept. It has chunks. It has the ability to allocate chunks of data or chunks of processing. So what you have to be careful of when you're dealing with Spring Batch is you have to align the JVM memory settings. So how many, you have to calculate the size of your Java code, and then you have to calculate the runtime memory footprint of that Java Spring Batch process. And then you have to realize how many times you can replicate that within your JVM size. So you need to understand how many JVMs or processes of the Spring Batch can fit within your current JVM settings. We started to calculate that and do all that. We found it easier to cut down the size of our JVMs and have a single Spring Batch process and its subtasking within the single JVM. This cut down on our garbage collection and also the problems that we ended up with garbage collection, pausing the JVM and all that other stuff. So by doing that, we were able to adjust the JVM size down and make sure that it was still good for the subtasking of 8 within our scenario. We have optimized our JVM and Spring Batch to only subtask to 8 subchunks. And this is because we found that the bang for the buck and the performance was not better when we went to 12 or 10 or 16 or 32 because of the JVM and the CPU processor that was stuck with the JVM and subtasks. We found that the performance overhead of switching back and forth to the subtasks was not optimal, and our optimal size was to get 7, 8 subtasks within our Spring Batch processing. Well, within that journey of doing all of those things, it was quite an extensive process and time-consuming process to run all these different tests. Because it was so time-consuming, really, we could have done all that work and just done single batch programs, batch Java programs. So tuning all the chunks, tuning all the JVMs, it really wasn't worth it. So my recommendation is to avoid Spring Batch if at all possible, because it puts you down the path of a lot of work. Same with the old days of using Hibernate. Hibernate has its persistence cache control, and the way that it can do SQL versus Hibernate SQL really doesn't make it a good process for the overall processing within a performance tight environment of DB2. The other thing that's a real problem with Hibernate is you're adding another layer of caching, and the optimistic locking and other locking that happens within Hibernate can also give you other issues within your DB2 Java performance type of situation. Another reason I don't like Hibernate is because there's so many logs to go through. You have the transaction log, the app server log, the web server log, and then you have the database log to track down problems. Not only do you have all these issues that get spread out across all these various logs, but it's just so much overhead to do all that logging within a high performance environment. So I really try to minimize all the Hibernate, all the Spring Batch within any of the Java performance or applications that really need performance, because it just creates more overhead and more debugging levels that you need to deal with. So the other thing that you get into when you're working with these frameworks is the configuration. And the configuration is always a difficult situation, because the configuration files always need to be tuned to the size of the data or size of the processing that you're dealing with. So I talked earlier about we have the different size environments. What you want to make sure that you're configuring the framework for that data size, because when you have the smaller data sizes, and then when you start to scale up within the larger environments, larger QA and prod-like environments, the configuration of the framework has to change. So you want to make sure that you have the reference architecture and the reference configuration for the framework. Incrementally changing that framework, you find out the different attributes of the Java program, and you find out the different attributes of the framework. So usually you have different settings, different Spring Batch settings for the different size environments, and you have to manage those configuration changes just like you manage your Java performance improvement changes. And these framework and configuration files are something that you need to move to the test environment, to the QA environment, to the prod-like environment, and then to the production environment. And it seems that as you scale up in these environments, the JVM, the commit scopes all widen out, so you have to have different framework settings. So you have a problem managing the source across these various environments, but you now have framework configurations that you need to manage across these environments. This can become a real problem, and it's just another thing that you need to manage for the availability, reliability, and the scalability issues. The other thing that was surprising was the security also ran into an issue when we tried to move these configuration files around. So the configuration issues can always be an issue. So here we have collected all the information for these unit work processes that are out of control. They're locking and syncing and causing all sorts of problems with themselves. So one of the first things we do when we have a performance issue is we make sure that the unit of work and the commit scope are validated so that we know those things are taken care of. But we first look into the Java process and look into the Java processing and see, is that module thread safe? And this is where you get into the application design and the application management of, who came up with this design, what is the module size, what kind of memory things are they using within the Java process. Because within Java, it's not like COBOL or something like that. There's syncing that's going on within the application. You have static methods that are force each calling thread to block until another thread is executing. So you have concurrency issues within the Java framework and the synchronizing of the Java application. So you really need to test whether your framework and your application is thread safe. And this is where you set up JUnit processing, automated processing, so that you can simulate your application doing millions or billions of Java executions every day. Serialization is another thing that happens within these frameworks. You have one main process, and then it kicks off other processes. Well, when those subtasks or those other processes come back to talk to the main one, what serialization or what commit, rollback, recovery type of things are happening within your Java process. You have to have a good way to have that unit of work be communicated across the main task and the subtasks, so that any serialization that you have is kept to a minimum. You don't want a subtask, a main task kicking off many subtasks and have one subtask finish very quickly and come back to the main task. So you want to have a even stance or even elapsed time of those processing things within the environment. And I just put this other thing down here, the duplicate Java classes within projects is always a crazy issue, in that last week's version is still in there and this week's version is all changed. So you really want to make sure that you're dealing with one Java package and not have duplicate classes within your projects. And this goes back to the design of your Java structures and your classes and your packages, and how you move in new packages within your environment. You need good naming standards, good packaging and directory structures, so that you aren't referencing the older packages within your path within your applications. And again, this is just something that's basic Java project management. The other thing, when you go into your performance tuning, you want to get as much detailed information about that thread. And here is an example of that thread that was just crazy running within this environment. And you can see there it was running for 2 hours, and it did a whole lot of work, and it aborted twice. So you can see the aborts there. We'll talk about this in more detail in the coming slides. So one of the first things when you have a performance problem is you want to start to look at the code logic, and look at the logic and how it's executing the different DB2 JDBC calls that are within it. Is it doing the SQL, and is it doing prepared statements? If you have Java DB2 processing, it should always be using prepared statements. It should always have a good SQL exception monitoring within the same Java module, in the same Java process, in the same Java class. The other thing is all the objects should be opened appropriately and closed appropriately. This goes to statements, result sets, and the connection object, and also to any cursors within it. This is just good DB2 SQL hygiene within it. This, by not handling the SQL and the prepared statements properly, you can screw up your subroutines, your transaction integrity, and this can also lead to things that aren't thread safe. So good handling within the Java environment also leads to good handling within the DB2 environment. They go hand in hand, and they're very, very important for overall performance and overall rollback and recovery type of scenario. Database integrity is, paramount with everything that goes on. So one of the things that's been a real thing for our success is we have very, very precise and very, very good set of test data. And what that means is we set up a sample size of developer testing data so that they can get a full feel of what the production environment is going to be. Since we're dealing with a database that has literally almost 100 billion number of rows within the database, we have 1 in a million situations that happen thousands and thousands of times. And when you get into the combinations of those 1 in a million data situations, the Java process and the Java logic needs to be able to handle those extreme, 1 in a million type of situations. So we've curated a set of sample data, and I really encourage everybody to set up a sample size of boundary data for extreme situations for your data values, extreme data situations for your business environment, picking up a customer that has, all sorts of returns or all sorts of credits and debits in their account, all sorts of different logical situations. Pick up the most complicated customer that you can and put that into your test data, in your test data, so that you can see how your application process handles it. The other thing is we always try to simulate, in our test data progression, we have a small sample size, a bigger sample size, and then almost like a single partition sample size. Within that, we monitor how the hash maps and all the memory objects are being used within that application. So within our JUnit testing and our automated testing that's happening, we have reports that say, okay, within this small environment, this hash map or this vector or these arrays that are used in the Java object or in the framework take up this much memory. And okay, if they project that to the next sample size of our test data, we can see that those hash maps have grown, and that has an implication on the JVM and the JVM size if that JVM is shared between concurrent Java processes. So you can understand that object point analysis and that process point analysis by looking at those memory allocations of those hash maps and those vectors. And again, this goes into, if you have a lot of memory objects in the JVM, you're going to have potentially a lot of issues. And this goes again into your management and support structures, so you have a good Java development environment, application development environment, so you can check these things off as the test data is being used within your different environments. So this is getting a good stream flow of what are the checklist components for analyzing performance as they go through the development process, because you can't have these Java performance problems in production. It just would it would make the news with some of the systems that I've dealt with. So you want to have documentation that's generated off of all these process points and all these thread safe points and how it's documented through the different environments. And this doesn't have to be, there's a lot of people that want to have a very rigid type of performance stress testing environment, and I'm a big fan of having a regimented way of doing this, but I've seen some informal processes that have been very, very effective at clients also. Experienced managers have documentation, have going through the business requirements and the functionality, and they're spectacular. So it really depends on your shop and depends on your support structures that you've got. But this is what has worked and what I've seen at various clients doing performance reviews. So one of the things is you want to make sure that you have as much automated testing as possible. JUnit testing is huge. In the notes, you can see some of the things that we set up. We have a lot of the boundary tests within our data, generating extreme data for different things. I'm a big fan of making sure that we migrate all the DB2 production statistics down to all of the DevOps environments, no matter how big or small they are. They all have the production statistics. So when a DB2 explain is done and captured by the application developer, that they get a true understanding of what kind of access path they're going to do. I've already talked about the different sizes of the data. Make sure that you test those broad situations. And one of the things that used to be a big issue, but not so much anymore, was the platform to platform conversions. When dealing with money, when you went from EBCDIC to Unicode, Unicode to Unicode, Unicode to ASCII, or EBCDIC to ASCII, you had to make sure that you handled the money correctly. This is the data transformations of the different code bases and the different Unicode to ASCII versions. There are so many ASCII versions, you really want to be careful with that. It used to be a major issue, but now not so much. But again, this goes into your automated testing that you're going to be dealing with. A lot of tools that are within the IDEs that are out there, the Visual Studio, and also a lot of people are still using the Rational Application Developer within their environments. One of the things that's there is the ability to know how much memory is being consumed by your hash maps, your vectors, and your other memory objects. And then when you can see if you run that Java process to what's going to be a full checkpoint or a full commit point, does garbage collection happen? And if garbage collection happens, how long will it take for garbage collection to happen within that Java process? And this is where you get into the IDEs, because most of them have the Java profiler built in. RAD especially does, and so does Visual Studio. In some of the clients that I've been at, I've been able to discover where they thought they were committing something. One part of the Java process was sneaking out and doing 60,000 extra SQL calls within a process for every Java unit of work that was going. Again, management of libraries. Java classes were used from old releases. They had an inadvertent class and package within the package of the release. So it's very, very telling that they didn't have a good handle on their infrastructure. Also discovered that the process coming from the website into the Java batch processing was doing validation all over again. So not only was the data validated within the web app, but the data validation routines were also being used again and again and again. So they were validating the data many, many times. So by doing a profile, you can see the full extent of your unit of work and understanding on all the logic flow that's happening within that environment. The other aspect of things is you want to make sure that you understand all the size and how those Java memory objects go against the JVM. And again, understand your looping, your arrays, and your memory objects within your process. Java profiling, set up an automated profiler so you can get thread statistics, monitor statistics, and visualize where you're spending time within your application. This is something, again, you want to see the spelling error at the top of the screen, memory objects, hash tables, and everything else. The other thing is, since you can't do Java performance in a single threaded environment, you're going to have to involve concurrency and analyze the concurrent nature of your application and understand how to roll back, recover, and restart in a parallel concurrent environment. Murphy's Law always comes true, so you really need to understand what things are involved and what Java processes share or could be using other aspects of the database, what other Java memory structures are being involved within your transaction, within your unit of work, and where they could be possibly deadlocking. You want to understand within the database where are the different Java applications inserting and deleting within their unit of work process. Do they do all the selects first and then quickly do the insert, updates, and deletes and then do the commit? Or do they do it in the other direction where they do all their inserts, updates, and deletes first, and then that drives some of the select processing? You want to understand the concurrency that happens and where those things are taking locks, because by taking locks, they're stopping the database processing and potentially locking things up, and that's could be what's happening within our example. So this is our example. All the red stuff is really, really bad, and the most important red stuff is the aborts that are happening within that, because that means a rollback and a recovery or some type of restart was done. And if we had an abort, we have no idea what the data integrity is. So getting the information is critical, and understanding that this situation is completely unacceptable and should never have been put in production whatsoever. One of the things that I'm a huge fan of is converting all the basic Java to Db2 native stored procedures. This helps remove the dynamic hibernate SQL statements. This reduces dramatically the CPU and the overall total cost. And by having Db2 native stored procedures, it makes your Java even more zip exploitive of the CPU resources that you've got. Db2 native stored procedures are fantastic for your Java workloads. Not Java stored procedures, but having all the SQL packaged within a Db2 native stored procedure. This is very, very important, and we'll talk about this in a few more details as we go on here. But the other thing is you want to make sure that when you're dealing with those concurrency issues, that any stale cache data problems, when you're handing things off from a Spring Batch main process to a subtask, you have the potential for stale cache, and this can cause reference data issues, or it can cause transactions unit of work issues. So you want to make sure that you understand what data is being passed along or passed within the main task and the subtask. This is where you get into local cache and other servers and clouds, where if you're sharing things across cloud environments, you can get into failover situations or bad cache or stale cache situations. You never want to allow cache to be pushed over environments or even JVMs. JVM sharing or passing things through JVMs, it can be done, but it doesn't really help your performance because there's a lot of syncing things that can have to happen within that. So some situations I've run into when I've done performance reviews, well, they can't really take that logic out of the Java process and convert it into a DB2 native stored procedure. But what they can do is change it into an execute batch Java situation. And this is where, if you can do enough research on your unit of work, and you can handle your unit of work and your JDBC connection, you can say auto commit false, do your prepared statements with your prepared parameter markers, and then you can do a batch size of 10, 25, 100, and this will exploit the DB2. Again, beware of the stale cache issues, but you can do 100 SQL statements within that batch process, and then you can do a commit after it, and that can be your unit of work. It can be very, very effective for simulating a DB2 stored procedure. This is one thing that I've done with some clients where putting things in a stored procedure wasn't available at that time. So here, every problem that we had here with the aborts, did any of the aborts happen after updates or commits? So you really want to understand where your abend happened and why didn't the program cease to execute. So obviously we have a unit of work issue that is a huge, huge recovery restart problem. The other thing is you want to start to look at the SQL loops that are happening within your environment. And if open and closes are different, here we have 1.1 million that are different. This obviously shows that we have a thread safe potential situation. And we obviously have a logic issue. So looping is a real problem. And if this is, this was updating customer data, we could potentially have 1 million problems within our database. The other thing is we have lock tables. So we are experiencing some lock escalation within our process. One of the things that when you go through your Java processing and performance testing is you want to make sure that you don't get any lock escalation for any of your tables or any of your environment. This is very, very vital, having a lock escalation. Which tables did we escalate? Was this a single table that was escalated 7 times, or was this something that the application was doing with a lock table statement within an SQL statement? The describes, we have 3.9 million of these describes. That means that the looping that is being done within the process is issuing the prepared statement 3.9 million times. This is unnecessary even in a standard batch Java process, because the looping is done incorrectly and the prepared SQL statement is in that loop. That should be out of that loop, and it wouldn't be even required in a stored procedure. So that's 3.9 million processes that could be eliminated from your Java performance. Again, large number of prepares. If you had this in a Java native stored procedure, this prepare wouldn't be necessary, 3.4 million of those. So we eliminated 3.9 describes, and now we eliminate 3.4 million prepares. That's almost 7 million processes that we've eliminated from this Java execution, and it's a huge performance improvement not doing these extra SQL prepares and describes. Loop issues, abort should always be 0. Open and close cursor always should be equal. Lock table should never be encountered. The number of describes is a logic problem within the Java application. The number of prepares is out of control. It should never be preparing. You should only be going through the loop. And again, if this was a stored procedure, we could lose the overhead of the 7 million prepares and describes that we're executing. A lot of Java processes were built in the early 2000s, and they have many, many connections. You really want to look at how many connections you're managing within your environment. I had one situation where they were starting out a process on the web, referencing DB2 LUW, going to ZOS to get some other data, going to another package that was running on Oracle, and then they were using inbound and outbound queues to do inventory and package scheduling within the warehouse. So within this, they had many, many different unit of work and running into those connections and those recoverabilities. I demonstrated their performance problems within this environment and how unrealistic it was by just having them reference all these environments and just displaying a timestamp. And this is showed them how doing this within this application design was just really ridiculous. The other thing is you have to make sure that you mine the state of all your connections. You want to understand how the application is doing all of its unit of work, and you want to make sure that you have your unit of work and each OS documented in, if it's a cloud environment, if it's a ZOS environment, or if it's a Kubernetes or some type of setting. You want to make sure that you're understanding the unit of work that crosses within that environment. Because when you get into recovery and rollbacks and recovery issues, you want to make sure that you take care of that situation. So I talked already about the edge and boundary test data that we have, but you want to make sure that you have that consolidated within your teams, and it always reflects the complexity of the business. Have those really tough customer situations with returns or with overpayments or with other unique company complexity data, and have those things done within your environment, and understand how many test runs actually need to be taken to demonstrate the performance and the rollback and recovery within your environment. This is very important. Some of the performance problems that I've come across that I've improved is changing a lot of the Java applications to using instead of prepared statements and controlling the logic, and changing them into DB2 native store procedures, which has been fantastic for centralizing code that can be referenced from anywhere because it's within the DB2 system. So you can centralize that business logic within that DB2 native store procedure. It really works out well. The other thing is when you get into Java performance problems, there are bigger things that are impacting the Java that's running within your application. And this is where you get into the number of ZOS, DB2, parallelism you can have within your environment. Excuse me. You need to know your understanding of how many zips are available because Java tries to run on the zip processors, and if you don't have your zip processors or your workload manager settings properly done, those can impact the performance. One of the newer Java applications that I was working at with one of my clients was a brand new Java application, brand new database, brand new performance aspects. They forgot to put their Java workloads in the workload manager scope. And they didn't have those new processes defined in workload manager. So when they tried to run their new Java process within the environment, it got nothing as far as production resources because it was in the default, no CPU allocated to it. So it wasn't getting any production CPU priorities. Once we got it defined into the WLM and we gave it velocity and other types of settings within WLM, we were able to get the Java processes to work and dominate on the zip processors, and the performance improved almost 10 times within that environment. So know the service levels and know the WLM settings that you've got. And also, you want to make sure that you understand when they're running on the zip processors. Are there other things that are happening within your environment that are doing things on the zip processors? This gets into the DR offloads, the cloning of the systems, any huge IO aspects of image copies. So understand what things that are going against your environment. There are bigger things that are going on within your complex, within your cloud, within your Kubernetes settings, within everything. It can, one of the things that I really continue to run into is the leveraging of the zip processors is being done by more and more Java applications within all the shops within the ZOS client base that I work with. By dominating those zip processors and shifting the Java workload over to the zip processors, those zip processors are getting more and more busy. So you really need to make sure that your workload is categorized correctly in Workload Manager so that you get enough of those allocations. The other thing, you'll be really amazed at how fast things run on the zip processors. Whereas the zip processors, their speed of CPU is usually not capped. The general processors running your Java environment are sometimes capped. So what do? We validate everything against a small development database. We understand all the locks that are acquired, released. We understand all the rollback recovery situations. We abort the Java process. We make sure that it can do recovery, and we do this against the development environment, a small thing that goes against the full database. Then we run it against a single partition within our partition type of processing to separate out the process and go against multiple partitions at once. This is where we start to get a understanding of the concurrency of the application and get partition independence. This is, again, we do a repeatedly run, roll back and recover and restart. And this is where we validate that there are absolutely no issues with the unit of works, the commit scopes, or anything that's going against a partition. Then we run against a fraction of a single partition. Again, we validate that there's no sysplex, cluster, pod, VM capacity issues. And we make sure that we have automation that if a process dies, that it can automatically be recovered and restarted without human intervention. This helps everyone with eliminating all the late calls at night because something always seems to go bump in the night. But this is also where we certify that no locking or lock escalation issues happen within our situation, within our database configuration and our Java performance. Then we validate the storage efficiency. We've moved things around to different disk storage devices, and we make sure that everything can handle the network capacity and the storage efficiency so that we can get the throughput. Every now and then we'll find something that some of our source files that are moved to different volumes and weren't spread out across different devices. We find that to be a annoyance that happens sometimes. So when we look at the infrastructure, you're not just thinking of the sysplex, but you're also thinking of the cluster, the pod, the Kubernetes settings. Now I'm starting to run into limited zip processors that are available. I experienced this recently with one of our main processes that was running overnight. It was not getting capacity. It usually ran in about 40 minutes, and it wasn't able to get zip processors, and it was already running an hour and a half because it couldn't get the zip processors. So this is where we got into the WLM settings and the workload capacity management, capacity prioritization. This is where you get into the management meetings and whose process is most important. Is it the people that are buying or selling, or is it the overall maintenance of the system? This is where also you get into looking at the iteration and the network processing. And this is where going to stored procedures that eliminate some of your network trips can also help out with that performance. So in summary, avoid the frameworks if you can. Know your commit scopes, your security authorizations, and your unit of works. Know your JVM configs. The garbage collection frequency is huge. Understand the packages and only use one plan. Stay away from any open source package if at all possible because of the security liabilities. Use the IDE profiling and debug processing, and test your unit of work, your transactions and threads safe, and make sure that you understand all your failover and scalability issues with the cloud, the Kubernetes, the LPAR, the server, the apps. Understand all your unit of work. All the things that we talked about in the air process was an issue, and I definitely look at all your SQL etiquette to make sure that you're doing all the things right within your DB2 environment, and make sure that you close and clean up all the database resources and leverage DB2 native stored procedures as often as possible. So thank you very much for listening today. I really appreciate it. Share these tips with everyone, and if you have any questions or comments, you can reach me through email. Thank you very much.
Thanks very much, Dave. I also want to mention that I took the time to upload Dave's presentation. If you want the presentation prior to leaving the session today, please feel free to grab it. As the people that stayed all the way through, it is yours. I will be putting it up on the replay blog, but you can get it right now. So there's on the control panel for GoToWebinar, there's a place where you can see the handouts, and you'll see it right there. Great job, Dave. Let me take back control. I can finish off the presentation here, and or the show rather. You did the presentation. I'm just doing stuff here. So let me move on. And the last thing, of course, we need to do is to ask our famous last question, which is always, did you learn something? We'd like to give people a chance to give us feedback on how useful people found the show. And everybody that's here is voting. That's fantastic. Great job, Dave. Great job.
Appreciate it.
And
thank you.
There's your results. 100% of our audience learned something. We like to see that number too.
Yep.
And
it kept it under an hour.
You did pretty well. Yeah, good stuff. It all fits in as long as we finish up by that magic 12:15 the Eastern time zone, so people don't miss their lunch and feel sad. Then we're doing real well. So with that, let me just get over here and cue our world famous theme music here, and get that going. Get the volume up a little bit. So once again, let me thank you for another great show and service to the DB2 community, Dave. Everybody have a great weekend. We're having some wonderful summer-like weather up here, so we're kind of enjoying that. As we don't seem to get enough of that up here in Canada, but we're enjoying it today. The pool will be open later on, so stop by. Take care.
All right. Sounds good. Thanks a lot, Martin. I really appreciate it. I'm sorry we're going to miss you in Philly.
Yeah, well, it's getting to that point, and some things just seem to come up. Take care, and we'll see you soon on the next Future Night Show next month.
All right. Take care.
Bye-bye.
Bye-bye.